Welcome to Overnight Success, the podcast where we celebrate the incredible journeys of entrepreneurs and visionaries. While there's no such thing as true overnight success, hearing their stories of determination, persistence, and resilience can inspire us all. Presented by Draper University and hosted by Joannou.
I want to quickly mention that none of this is investment advice or financial advice, trading advice, or any sort of advice. And we do not recommend any cryptocurrency or investing in any projects. We're just showcasing the stories of founders.
Greg, how you doing, my friend? Super excited to have you on the show.
Super excited to be here, Chris. Thank you so much for having me.
I am excited to talk about Akash Network. I usually try and give the audience a little bit of context, but we've got lots to talk about in terms of decentralized machine learning. We've got everything that's happening in AI, so I don't want to dwell on it too long, but I do want to give the audience an understanding of who they're speaking to. Can you give me the quick highlight reel, I suppose, of your entrepreneurial career and how you kind of ended up, landing working on this problem?
Of course. So it's pronounced Akash Network. So Akash means the sky in Sanskrit.
Okay, so I screwed that up.
No worries. Most people don't know the background. Akash means the sky in Sanskrit is where the clouds meet. Some translations, Akash goes by the first element or the ether as well. But the name really came about because it is a cloud of clouds, a super cloud. So sky is a super cloud, right? So that's how we chose the name. And also, if you actually translate that in English, it is Sky Network. And if you put things together, you end up with Skynet. I don't know if you're old enough to remember Skynet, but
I think it's coming to the forefront at the moment again.
Correct. So imagine an unstoppable, censorship-resistant GPU cloud that can be used by humans and machines, and no one can censor you from it. And anyway, so that's the name where it came from. My name is Greg, and I'm the founder CEO for Overclock Labs, the creators of Akash Network. And I am one of the inventors of Akash Network. My entrepreneurial journey really began, I think, in India when I was, 14. I was making websites. This is during the internet era, the first internet era in '99. Learning HTML was similar to learning DT. So I was able to make money doing that, selling website services and whatnot. I learned how to program before the internet, and I used books and open source software essentially to learn, and that's why I'm considered
HTML for Dummies.
I had that book. I did have the book, HTML for Dummies. Yeah, it's funny you mentioned that because I remember that book. And I also had the Kernighan C that I learned C and C++ after that. And my journey, like I said, before the internet, I was shipping floppy disks, my software in floppy disks. Obviously, that was very limiting as to how much I could ship. So the internet came and it changed the way I ship software, right? So now I can essentially build a server or a computer and ship that computer to this data center that will sit there and deliver my software to millions of people versus me trying to mail disks using mail. And max I could do was maybe 300, 400 on a good month, right? So that was a big shift for me in terms of how we deliver software, and big shift for a lot of people around the world. And that led to the first internet era, right? So a lot of people built lots of data centers, and then the bust came, and a lot of companies went out of business. But they had all these data centers that started consolidating, right? And some companies like Amazon and Google figured out how to use their data centers to essentially convert the cost center in a profit center, because these companies were inherently really good software companies, and they understood that if you can package this compute power using an API and give that to developers, it's something that's very attractive. So that's really the birth of the cloud, and I was very, very much active there. I founded a company called Angel Hack in 2011.
Oh, another one, very famous.
Yes, during the cloud era, right? So we kickstarted the Web 2 era, right? We had a community of 150,000 developers across 50 cities around the world. And cloud came and changed the way we ship software, right? So that enabled a lot of companies, really kickstarted companies like Netflix or Dropbox during this time to really take off and use the cloud as a foundation for growth. But then we quickly noticed that cloud, even though it's great to get started and very flexible to scale compared to the old model, it had limitations, severe limitations in terms of cost, right? And also it was also turning out to be extremely anti-market, free market, in the sense that it was stifling innovation when it comes to open source software, right? The model was increasingly becoming closed, and that really comes with a lot of power, right? I mean, a lot of power corrupts, and no matter how good a company motto could be, like, it eventually leads to this hyper concentration and corruption. And that's exactly what happened with the cloud. And when we noticed these patterns as an industry very, very earlier on, like 2013, 2012 timeframe, and a lot of people like me, open source contributors, started like creating this a way to get out of the cloud, right? So that's when the container native technologies sort of started popping up. You hear terms like Kubernetes and Docker and all these like technologies. I was very, very early in that era. I made some contributions to Kubernetes, those contributions are still very actively used today by the cloud. Not only us in the industry, but also we had like academia started like looking at this cloud as a problem. One of the universities, Cornell, actually proposed the idea of a super cloud in 2015 of using a heterogeneous devices to create a homogeneous layer that users could use in a similar way that you would use Amazon and Google, uh, but leverage underutilized capacity or capacity that's distributed across the globe. We thought that idea was fantastic. And we essentially added to that idea a mechanism to trade compute cycles. So this way, the super cloud was initially limited to just a single company, but we made super cloud more accessible by lots of companies, right? So we really added a cloud model to the super cloud, for lack of a better word. And that was a foundation for Akash Network. We wrote the paper 5 years ago, exactly on March 13th, actually, it's coming up. We wrote the paper 5 years ago. We published the paper that a lot of folks in the industry really liked the idea behind a super cloud. And we built it in 3 years. We launched it about 2 years. We launched the network about 2 years ago. And right now, Akash is the world's first and most viable open cloud that's decentralized, permissionless, and self-sovereign. And it has an incredible marketplace to trade compute cycles. Right now, about 50 providers provide compute to Akash. All ranges of providers, all the way from big guys like Equinix's of the world to smaller providers to people with excess compute, right? And we have about hundreds of applications running on Akash. Some of the popular ones would be Osmosis from Cosmos. We have Juno Network. We have Stargaze. We have Omniflix and Research. And we have some of the really incredible decentralized applications leveraging this decentralized cloud. I believe around 30% of Cosmos ecosystem has used Akash or are using Akash in some form or the other. Cosmos ecosystem, because Akash also is the first Cosmos chain besides Cosmos Hub. We were first in lots of different ways, but Akash is the first IBC or interoperable blockchain that did the first transaction between Cosmos and Akash. And so that puts us in a market first place with Cosmos. And most Cosmos projects, when they launch, they use Akash some form or the other, right? So we have that advantage. And that's why we have quite a lot of adoption from Cosmos ecosystem. But we are also slowly seeing adoption from other ecosystems with Ethereum and Solana as it proliferates. And the most exciting adoption and the most exciting thing that's coming for Akash is artificial intelligence. And yeah, I'd love to go all in.
Absolutely. Can I take it just one step back? I love to ask the question, and I'm thinking it, aside from the paper that you wrote there that's kind of been instrumental in the super cloud, the question that I asked the guest is, can they kind of pinpoint the time that they kind of understood blockchain was going to change everything, right? Because like all the entrepreneurs have this story around the baseball cards or whatever, that kind of journey when they were young. And then, but I'm curious as to what did it for you where you're like, hey, like basically you're dedicating your life to it. So always curious to hear.
What did it for me? I don't think it was one single moment, to be
Mm-hmm.
honest with you. I mean, we heard about Ethereum. I mean, I obviously owned Bitcoin 2013, played around with it. It was not as serious, I would say, like, I'll put all my wealth in Bitcoin kind of mode. It was still a very, I mean, me, a San Francisco engineer, like established experience San Francisco engineer, right? So for me, it was all really about the tech. Sure, money was one thing, but the tech was really all about. And Bitcoin was super exciting that I could get access to things that I couldn't get access to using Bitcoin. So that was my entry. But the game changer was Ethereum for me. So someone, I believe it was 2015, someone at the 2016 timeframe, in one of the Go conferences, someone told me about Ethereum, and it made sense in the sense, oh, we can actually build decentralized applications for us. And we were already with first version of Akash, even before Akash was a thing. Overclock Labs, a company I work for, we all work for, we built a technology using Kubernetes and using Docker, edge-enabled compute network, in the sense like if you have a data center, you can install our appliance, and that appliance, that data center becomes edge optimized, right? And it was very, very interesting. I was doing a lot of work on like scheduling, in the sense like how do you do data availability and fault tolerance. And it was I was a big fan of optimistic schedulers, where there is no centralized lock that could essentially lead to deadlock problems, in the sense like every node is optimistic about other nodes, right? So not to get into too details,
Mm-hmm.
the core of the optimistic scheduling was there should not be a central system that could fail and further cause other problems, right? So we were building a peer-to-peer interaction mechanism between these nodes, and we were using BitTorrent for replication, and then we had Merkle Tree for integrity checks, right? So you put Merkle Tree and BitTorrent together, you end up with a blockchain. So, and then we were like, okay, Ethereum was like, well, you don't have to go build your own blockchain, you can use Ethereum to do it. And that was very fascinating for us. So it was not like one moment, it was sort of like already in our ethos that we need a peer-to-peer system. But then the real click came about when I learned about tokens, right? Like the tokens really opened my eyes, added a new perspective in terms of sustainability for open source software. A big challenge with open source software back then, even now to a certain degree, and I beat myself up for why open source people don't see it this way, is sustainability. Like you can launch an open source software, but how do you incentivize its growth and evolution without a company sponsoring it, without donations, without anything, right? Like, and companies like Amazon just take the software and just make incredible money on it, right? So how do you really like capture that value in a way that you can actually sustain a network's development? So I think that's where the network component becomes critical for open source software. And through the network component, we're going to introduce a monetary mechanism, or a network, a value mechanism within the network, a network of value, right? And you can embody that value in this token. And that's really opened my eyes. I'm like, okay, now we can actually create a truly open source cloud network without a single company, right? So, and then we did a lot of research, and we played around quite a lot with Ethereum in 2017 timeframe. Ethereum couldn't really, at least even now, actually, it wasn't scalable at all to what we needed as a cloud infrastructure. So we ended up building our own blockchain. And Cosmos, the folks at Cosmos, back then it was called Tendermint, they had an interesting idea of like, look, you don't have to build your own blockchain. Everybody wants to build their own. Any serious person trying to do decentralized applications with distributed systems background, we look at Ethereum and be like, this is not going to work for us, right? So the folks at Tendermint really understood that, and they built a library for people like us that to build layer one blockchains, right?
Mm-hmm.
Called Tendermint. So that handle the core consensus mechanism, and they introduced the idea of a delegated proof of stake in that, and that was very attractive for us. And then that eventually became, so we were one of the first people to use it, and went through a lot of pains, and that eventually became Cosmos SDK. We ended up building a lot of the modules for Cosmos SDK, and Overclock Labs also is a core contributor to Cosmos SDK. and we've been evolving ever since. So yeah, so it's not one moment, but really that realization that, hey, blockchain is cool. It's amazing. It's really good technology for permissionless rights, right? That's why I look at it. If you have permission rights, a database is the best system. For permissionless rights, blockchain is a great system. But now the question is like, well, how do you scale? Well, you can do proof of work. It's very hard to scale. So you do proof of stake. Well, how do you keep proof of stake secure? You need a value to the token. Well, can you do what other things like what other values the token can bring? It can bring sustainability. It can create network effects. It can create communities. It can bring a lot of things that open source software did not have. So I look at, if you were to put a category on like what kind of open source software are we building, I would classify this as tokenized open source software. So just like open source software, we had like the first model is fully open source, and then we had the open core model where you would open source some of your code, but the good stuff you would hide behind the paywall, which is not really open source. But now nobody likes that model. And now the question is, how do you create a truly open source software and give everything out, like all the features, capabilities, and somehow capture value and sustain, right? That's where tokenized open source software comes into play. I think is a much superior model than traditional open source software. So I look at, crypto, blockchain, Web3, call it as evolutions of our governance structures and coordination structures, right? And open source being the foundation of it.
Well, so this probably leads perfectly to the conversation I wanted to have around AI, right? And you got all these, it seems like they are popping up overnight, and the chains that are kind of just plugged into Chat GPT and OpenAI, and they're just kind of popping up everywhere. I don't know how they're getting listed so quickly, because I know it's a pain in the ass to get listed, but they're popping up everywhere. And it seems that everyone's just kind of plugging into the same source, and that source is essentially Microsoft. Now, I'd love to just get your opinion on how we can do decentralized AI.
Right. So just a quick thing about these listings. We're seeing quite a lot of like AI projects in crypto popping up and getting listed and getting like a lot of attention. Be aware of any of these. Anything that has a GPT in the title generally is a scam. And I've seen some of these scams, crypto GPT, chain GPT. There are a bunch of these, and none of them have open source software. They're all closed. They're all mostly open API wrappers. Like a company called, I believe it was, I keep confusing between Chain GPT or Crypto GPT. Is one of these protocols literally put an open API wrapper on their website and called it their own. And I think that's straight up scam, right? So just be aware of that. I actually went and typed in the chat bar who made you, and it said OpenAI. So it's just horrible. The other guys were a little bit better, but so like a lot of these guys are just scammers popping up and grabbing attention, and all of a sudden you see a Twitter account that has 100,000 followers or that it was created 2 months ago. Generally means it's a scam, but they're legit ones. It hasn't launched. They like BitTensor, which is an incredible network, and none of them have listings, by the way. None of them have this attention the GPTs have, right? So anyway, so
we build in the tech, I suppose.
It's, I believe OpenAI trademarked GPT, and they're going to go after all these products with GPT in the title.
Yeah.
So most likely we'll see good legal enforcement for a lot of these things, but also like, yeah, and don't generally go to something that doesn't have a product or the source code is open, right? You have to have open source for decentralization to function. Anytime you see someone's GitHub, if it's non-existent, it is a scam, most likely. And they'll say, oh, we'll eventually open source, but do not fall for that. If you will eventually open source, there's no rush for you to list, so just you can have a project and that's not listed, that doesn't have a token yet, that's closed source, that's fine. But I think projects that are listed in public should be open source, hands down. There's no excuse for that, right? So especially in crypto, right? It's about verification. Without verification, auditing, anyway. Artificial intelligence is incredible. It is perhaps the most important technological shift of our society. The power has exponentially greater than anything we've seen, and there's no doubt. And the challenge right now is it is becoming to be a feudalistic society. People that have access to AI are going to win out over people that do not have access. And companies that control this access are going to amass so much power. If we don't do something about it now, we're going to lose out because it's happening very, very, very fast.
Mhm.
So companies like OpenAI, which is essentially Microsoft AI, I think we should just change the name now because they're pretty much owned by Microsoft, right? They make the most advanced models, and they're completely closed source. The most advanced model out there that's public is GPT-4. I haven't seen the Google I/O today, so probably I'm missing out a few things. But GPT-4 happens to be the most advanced model. But if you look at lineage of GPT stands for Generative Pre-trained Transformer. The transformer in GPT really came from Google. So Google wrote a paper called "Attention is All You Need." Funny enough, one of the authors of the paper is Ilya from Near Protocol.
Right.
So that paper is considered the Bitcoin of AI, right? That was a very transformational paper. And
Wow.
from there, we got the several LLMs built out of it, and or LLMs in the sense large language models. And in that large language models, there are several use cases for large language models. One of them happened to be generative model, right? So GPT is essentially a generative pre-trained. That means it's already trained on a data set that's from OpenAI AI was able to acquire through various public sources, and transformer that really came from Google. There are summarizers, there are classifiers, a whole lot of like LLMs that could be built on like pre-trained transformer model, and GPT happened to be the generative pre-trained, right? And GPT-4 is the most advanced, and Chat GPT is based on GPT-4. But the thing interesting thing we're seeing is there are open source clones or open source GPT models that are actually getting to be really, really good as GPT-4 in some cases, right? And the time it's taking from a OpenAI release to a clone is shortening really quickly. Why? Well, because a lot of the stuff is just open source, not, OpenAI did not invent a lot of these things. Of course, they've done incredible work. I'm not trying to discredit their work. I mean, they've done amazing work, but I think the foundation of this work came from companies like Google and companies, Facebook actually also contributing to the open source world, right? The research side of things. What OpenAI has that other people don't have is GPUs. That's where the power comes in, right? It's not the model, it's really the GPUs and the data set. That's where the power is, right? So OpenAI was able to secure great deals with NVIDIA, with cloud providers to be able to get ahead in the game, but I don't think they have the advantage anymore, especially with what kind of attention AI is getting. So it's very, very important that we are not like, we're not that this technology access is available, and models like Llama, which really came from Facebook, and Alpaca, which is a model based on Llama, which is equivalent to GPT 3.5, I believe, as powerful as 3.5. A model called Dolly, which is an open source model from, not Dolly, Dolly, from Databricks, that's as good as GPT 3.5. And there's another model that's about 70 to 80% good as GPT-4, but the gap is reducing very quickly. That gives us incredible opportunity because we can take that, and if we have a way to add GPUs to this model and a data set, we can create a good alternative open source AI that is actually the foundation for decentralized AI. So that's really Akash's vision. Akash's mission is to provide a layer, a super cloud, a AI super cloud that'll power this open source AI movement, right? And GPUs right now are extremely hard to get, especially the high-end ones, right? So if you look at the landscape for GPUs, the high-end GPUs or the GPUs that are idle for machine learning, which are H100s and A100s, are impossible to get, even on the cloud, right? So if you are a AI startup trying to get some cloud nodes on Amazon or Google to run your A100 to run on A100, you cannot. They're just not available unless you know someone higher up, right? And forget buying from the market. And people are buying these chips left and right. Elon Musk bought about 10,000 of them, I think, a few weeks ago. of H100s for his new AI company. So everybody is obviously jumping on the AI train, and everybody needs these chips. The only way we will be able to get chips is through a peer-to-peer marketplace, and that's really what Akash is building. And we see quite a lot of supply. We have about 5 different sources of supply we have noticed, but a big portion of GPUs are actually with crypto miners, especially the ones that invested quite a lot during to mine ETH, that post-merge really have nowhere to go, right? So we have in our inventory about 1 million GPUs that we have access to in our network alone, in our community, that we potentially want to bring it to market, right? So right now GPUs are on testnet. We are going with the incentivized testnet in a few weeks. That means we're going to incentivize folks to provide GPUs to the network as well as deploy. So this way we can distribute Akash Network to as many as people as possible. We're anticipating quite a lot of turnaround. But we have secured providers to launch the mainnet with A100s and H100s. So that's going to be very critical that we have high-end GPUs to get you the best machine learning experience possible.
Can I ask, and maybe using the Skynet analogy, right? And maybe for the non-technical listeners, right? Is it safe to say that if it's closed, right, it's a lot easier for the robots to take over, and if it's open, it's just a lot harder, like almost impossible, makes it impossible for AI to kind of capture the network? Is that a simple way of saying the benefits?
Not quite, right? Like so for someone to really take over the world, they need GPUs. Whoever has the power, GPUs are the oil.
Right.
Like you can have the most advanced tank, but without diesel, there's no point, right? Like, so you need the fuel for AI, right? The ones that control that fuel will be in the best position to control the world, if you think about it.
You're not going to go corrupt on us, mate, are you? I'm just...
What's that?
I'm making sure you're okay. You're not going to go evil on us, are you?
I mean, I can't. It's
good.
Not that I don't be evil. I can be evil. That's the whole point of decentralized networks, right? I mean, they're open. And we built Akash in a way that Overclock Labs, the company that built it, has no control over the network. In fact, we have about 280 contributors to the network. 17 of them work for Overclock Labs. If you look at some of the repositories on GitHub, if you look at all the closed issues, you go to issues and click on them and see the pull requests there. 9 out of 10 pull requests come from outside the company. It's very, very important that this model exists. If you go to Akash Network/community, and you'll see our communities, we have this idea of self-governing communities through special interest groups and working groups and steering committees, where the roadmap for what happens on Akash is proposed in an open setting. All the meetings transcribed and summarized are completely public. All the videos are completely public. Only meetings that we don't publicize are HR meetings, really, for the company. We don't have any internal product meetings ever. We do it in the public. We invite everybody to participate. And then you have more exclusive working groups that take the work from the special interest groups and start implementing stuff. And there's a bounty mechanism that incentivizes developers to contribute. So we have worked very, very, very hard to make sure that Overclock Labs has no control over Akash Network and will not have control over Akash Network. And it's very important for that, because the longevity, the sustainability model that I talked about needs to be rooted in a way that the company that created the network can go away and still be okay, right? So yeah, we built it. We built it very, very solid. It's very decentralized, and we operate one provider as a test provider. But there are about 50 providers on the network. So even if you take our provider offline, you still have 49 providers that are serving. With GPUs, we anticipate the provider to be a lot higher. Yeah, I can't control. The only question is, well, it'll be token holders that control the network, right? So the question is, we do have a non-custodial mechanism. There's no identifiable information on the blockchain. Anyone with a private key can essentially vote as long as they stake the tokens. So can bots acquire tokens using decentralized systems? Absolutely. In fact, we have AutoGPT. I don't know if you saw that, but AutoGPT can do wonderful things, and we made AutoGPT do multiple things about how we can get a bunch of AKT tokens and run its own models, train its own models on Akash without anyone cutting its keys off, right? So arguably, decentralized systems are a lot more, because they're censorship-resistant systems. AI's bots it'll be favorable for bots to use it. So that brings a challenge about like how are we going to censor? Is it I think that's going to reopen the challenge about censorship, and is there a mechanism to censor, right? So the way I look at this is really it depends on the people. If people want to shut something down, they should shut something down. And the decision should be a consensus from the public and not a decision of a single company or a single entity. And that's really where how I look at decentralization, right? Like,
yeah, and a lot of these layer one protocols, kind of some of the bigger names, are not that decentralized when you get down to it. Do I have that right?
Yeah. So I look at decentralization as an onion. You peel enough layers and you ask enough questions, right? The first layer is obviously technology, right? Technology is very decentralized. A lot of layer ones are decentralized in terms of who can participate in consensus. You don't need anyone's permission. So that's easy. And second layer is the governance, right? Governance, you start seeing some cracks. Yes, like a lot of the protocols are open governance, but yes, you have companies that amass enough voting power, like we saw with Anderson, voting in Ethereum proposals, sorry, in Uniswap proposals or whatnot.
Mm-hmm.
So we see some sort of centralization in the governance layer. We also see some centralization in the node layer, but theoretically they're decentralized, right? The question is, if they go away, can the network operate? Yeah, the network can still operate. Like if Lido goes away, Ethereum can still operate. And then if you peel enough layers, it really comes down to the attack vector, which is essentially who is building the network, who's actually writing the code. Because that person, if that person goes away, will the network survive? That's real
Right.
decentralization, right? So it's like layers. You peel enough layers, and you come down to like who's writing the code and who is proposing the change for this code base to actually reflect in a decentralized network. So I think decentralization has to go through, and we have worked very, very hard to decentralize that part, right? Code writing, code functioning part. Because we can decentralize there, everything else becomes decentralized, right? Because people that write code will obviously want part of the program, part of the network, right? So a lot of times our users, being developers, are developers, that contributors that contribute to the code end up being our users, because these are developers themselves. So it's a builder-built network, which is very fun because I use the network every day, right? Like I don't use DeFi much because I'm a developer. I maybe swap tokens once or twice a month, but I actually use Akash on a daily basis because I deploy software pretty much on a daily basis, right? Like as a developer. So yeah, to answer your question, will bots take over? That's a big conversation that keeps me up at night. Like I mean, decentralized systems make it easy because of censorship, limitations. But how do we manage? I think there will be some sort of moderation in terms of who gets the chips, and that moderation will be done in the public. It has to be done in the public.
Got it. So just switching gears, I suppose, decentralized machine learning, right? Because I kind of see, well, maybe bots taking over the IoT devices and actual robots. But I'm curious as to, you kind of famously coined the phrase decentralized machine learning. Can you explain a little bit about it and where it's headed?
Right. So it's very important for machine learning to be decentralized and owned by the public. That's established. Now the question is, who is actually building this decentralized vision? We started at the beginning of the show, my frustration about there are a lot of like grifters. Just avoid those GPT grifters, right? And the real people are, when I talk to real projects, they always talk in terms of trade-offs. And that's how we know a product is legit or not, right? It's very hard to do decentralized machine learning. Why? Because the latency for machine learning for the neural network is too high over a distributed network.
Mm-hmm.
So the cost of compute for a machine learning and neural network to be well trained, the cost of compute should be less than cost of communication.
Good.
Cost of communication should be less than cost of compute for it to be optimal, right? So if the nodes are decentralized or distributed, the cost of communication is much higher than the cost of compute. So it becomes very, very expensive. So in order for decentralization for machine learning to flourish, you need lots and lots of really cheap devices, huge network, and or you need to figure out how to optimize these batch sizes, right? So in that vein, there are several companies doing a lot of work in this area. The first company I would think about, I mean, Akash, we're obviously, our vision is to amass as many as computers as possible, as many as GPUs as possible, and offer a network for machine learning to flourish, right? So we are obviously, onboarding two type of machines, GPUs. One are the high-end, high memory GPUs called H100s and A100s. A lot of these GPUs are available, are a lot of people that machine learning companies that have them, since they're very hard to get, people are just buying them up, right? They're buying them up and keeping them. So there are a lot of companies, a lot of machine learning companies have them, they're not using them. So we're, incentivizing those folks to provide those chips on the network. And we have like a lot of like people that use the cloud essentially doing this pre-commit, pre-usage commits in order to get the deal to get access to those chips. We are having them put the network H100s on the network. So we're a secondary market for these high-end GPUs. And then we have the lower-end GPUs, or more less density GPUs like gaming machines and whatnot. They're not as powerful as H100s, but they have some use. They're better than CPUs, right? And that is distributed across the globe. A lot of the ETH miners, a lot of the crypto miners actually bought up quite a lot of GPUs. If you remember a few years ago, they're all just sitting on this idle capacity, right? So we're working very hard to bring these GPUs to the market. And then we have people that use these GPUs. In the decentralized machine learning space, the company called Jensen, it's not launched yet, it's very, very early. GENSYN, Jensen.
Oh, okay.
Jensen is what they are doing is they're building a machine learning layer that you could train on a heterogeneous device set. It's very, very important, right? Because they're taking each model and GPTs and the each LLMs, right, the GPT-4 and whatnot, and they're optimizing to run on a distributed cluster. So they'll be able to plug into Akash and use Akash network from the GPU standpoint, and they can do the training, right? And of course they understand, they're extremely smart people and they understand the trade-offs. So the question is, will they achieve the performance needed to have a functioning decentralized machine learning or not is up to the question. But judging from the team, I think they can. There's another protocol called BitTensor, which is one of my favorite protocols. So again, in machine learning, a big challenge is correcting the system, making sure that the system is doing things, that it's supposed to do. So there's always some form of human reinforcement, right? That's required. So BitTensor is providing the human reinforcement layer, which is incredible. So they actually have trained a model. I saw a demo. I think chat.bittensor.org. If you go to, you can actually play with the LLM. It's actually working incredibly well. There's another network called Fetch AI. Now, granted, I don't know too much about these folks. From what I see, is it's a very popular token. So I think it's one of the top 100 now. But they are a decentralized agent network. Now, agents are very important to do tasks for you.
Yeah.
Right? For example, so you can have, go, I don't know, get a task.
The travel agent and your financial advisor, all these kind of agents talking about?
The agent is a machine or some component that will do a task for you.
Yes.
So say you want to send an email. So, you can have an email agent that listens to an LLM and send the email for you. Or you want to hire somebody to deliver something on TaskRabbit. There's an agent that'll go do that for you, right? So we have these agents that, could be humans, it could be machines, it could be anything. And Fetch AI is building this agent network that can do things for you. They're very early stage. They are not, I don't think they're in production. The token is live, I believe. Again, none of this is financial advice, but,
I already have the disclaimer at the beginning. Don't worry.
Some of these tokens tend to have like a lot of market value, but that's what they are doing. And I think we're starting to see a DML stack or decentralized machine learning stack with Jensen, BitTensor, Fetch AI, and Akash Network, all at different levels, if you can see, right? Different functions, right? They're doing. And also we're seeing the infrastructure, right? We say RV, we collaborate quite a lot with RV, Graph Protocol, and LivePeer. With things about infrastructure protocols is they can be easily verticalized, right? Because they create the foundation really well. it's very important that our data today, GPT is trained on yours and my data. We gave for free, essentially. So it's taking our data and actually like capturing quite a lot of value, and I think that's wrong. So you should have control sovereignty about your data and what you want to do with your data. If you want to get paid, if you want to, I don't know, get whatever you want to do. I think that should be very primitive. And RV was solving the data ownership problem, and they're very so we're working with mechanisms where you can actually like reduce the latency for data load and whatnot. So I think we're going to see quite a lot of like decentralized data rights management, which is very important, and decentralized learning and inference and fine tuning, which Akash is providing, and then human element and actual execution of the models itself and the task element. So it's quite a lot. Like I think Masari will eventually probably create a DML category sometime, but Masari has a good analysis on the DePin category, which I think all of us kind of fall under, or decentralized physical infrastructure networks, they call them. And I'm very excited. DML is in a very, very early stages, but all of us are trying. I think we're very close to catching up to decentralized AI.
Right. Yes. I was curious as to what you were saying these trade-offs actually are, right? Is this the latency you mentioned, or it's kind of like the trade-off is the experience versus like I've got Netflix running on AWS, right? And I don't see any glitch in my viewing experience. Is this the trade-off we're talking ultimately for the consumer?
Right. So there are three parts for machine learning. One is the training, fine-tuning, and inference. So fine-tuning and training are literally taking the data set and like training on top of it. And fine-tuning is customizing the data set to your needs, right? So I don't know if you use this app called Lensa, which makes this face apps, right?
I see some pretty impressive headshots.
Right. So what that does is it takes Stable Diffusion, which is essentially a pre-trained model, right? A diffusion model, an open source diffusion model, and takes your pictures. I think I asked about 10, 20 pictures of yours, and fine tunes that with you as a subject. And then when you request images, that's basically inferencing. So you send it to the prompt and you infer on the fine-tuned data set, right? So for training, and the way training works for transformer models is essentially it's a neural network that's like talking to each, like, it's basically the amount of neurons is how much the power it gives. So it trains continuously on a large cluster, right? And the longer each neurons take to travel, the longer it takes to train. So the only way to reduce that is to reduce the amount of latency between these neurons, right?
Which is all these lower end IoT devices you're speaking of. Yeah.
No, that's very high. So latency is very high between lower end IoT devices. In fact, latency needs to be so low that these chips themselves, GPUs themselves, will have on-chip memory. Right. So, like for example, A100s have 80 gigabyte memory, and H100s too, 80 gigabyte on-chip memory. They can't even use machine memory because it's so slow. So now try doing that over a network, right? So that's the challenge. So if you want to train advanced models, you need low latency, very minimal message passing latency, right? Between two neurons. So if you had to do it in a decentralized way, that's not possible.
Got it.
And that's the challenge, right? That's what Jensen and a lot of the folks are trying to solve. And the trade-off is like, yeah, you can get lower cost, but training time is going to be higher. So you're never going to catch up to a GPT-4. And now there's fine-tuning. Fine-tuning is a little more permissive in the sense like, well, fine-tuning for Lensa, I think it was 1 hour to get your pictures, right? That's fine-tuning, right? Well, if it takes 2 hours or 3 hours, you're still fine, right? You can do it over a network. But training is very, very hard to do on a distributed network. I absolutely admire folks that are optimizing that. It takes a lot of work for us to get there, and we get in there very fast, right? And inference is basically just sending the prompt and getting the result. So every time you type ChatGPT, you're literally sending the ChatGPT a prompt, and you're getting back on the training set. And that is similar to a traditional web applications. It's not that sensitive on the type of GPUs. You can pretty much, sure, it's going to be a little faster than the others, but it's not going to be exponentially different in terms of like, I think GPT-4 was trained in 6 months from GPT 3.5, I believe. on a cluster of A100s. If that were to be done on other chips, it would take 3-4 years, right? So that's really the big trade-off. Yeah.
Greg, thank you very much for jumping on now and talking about Akash. I got it right now, mate. And I'm super excited to share your story and talk about the network with all the founders and entrepreneurs listening. Really appreciate your time.
Thank you so much.
For working for us.
This was fun.
Cheers,
Hope,
Thank you for listening to Overnight Success. We hope you enjoyed hearing from our guests and learning about their inspiring journeys. If you found this episode helpful, please subscribe and share it with your friends. And remember, with hard work and dedication, anything is possible.